Okay, so in front of us we have an Alienware RTX 3080. This is unfortunately one of those half-working cards, so rather than start with a resistance and voltage check, we're going to first try to boot into Windows and see the symptoms. So anyways, turning the card on. So I should note that I'm not exactly sure what the symptoms would be, as it kind of alternates between not posting, or in this case posting, but as you will eventually see, when we get to Windows, it starts to, well, it either crashes on driver install, or throws code 43 or artifacts. For code 43, this is typically only as a secondary card, as cards with code 43 that are GA102 based and have GDDR6X will usually just hang on post. And as for the artifacting, I don't really mean the artifacting itself, as you would see in my other videos. What I really mean is that the display will typically flicker on and off before permanently staying off and crashing the entire system. Okay, first things first, we want to go to Device Manager to see if the card has its drivers loaded. I'm not sure if it will. Okay, so the drivers are trying to install, and does it work? Apparently it does. Okay, so the drivers have installed and they look just fine. However, I can already tell this won't be for long, so let's actually try to run a game so you can see exactly what's actually wrong with this card. So in this case, the drivers did install, but it will just randomly crash, unfortunately, as you'll see in a moment. So the game's about to start, so it should crash pretty soon. In fact, I'll just let it play and we'll cut straight to the moment it crashes. Okay, so as you saw, the card crashed, I think. Yes, it did. So the caps lock key is unresponsive, so therefore the card is crashed. Let's turn off the computer and try to boot again. Okay, turning on the system. And this time, it never posts. So this card, after it crashes under load or on driver install in some cases, it will revert to a state in which that if you try to restart the computer, it can no longer display an image, so basically no post. Anyways, let's go ahead and run the VRAM test tools and try to determine exactly which memory bank is bad. And I am assuming it's memory, by the way. It could, of course, be the core or something else. Okay, so now that we're in the VRAM test tools, we're going to select option 2 for RTX 30 series cards. I should note that it'll auto-run mattes in a moment. So generally speaking, you shouldn't trust the auto-run results for at least the RTX 20 and GTX 10 series partition. So as you can see, it passes, which is not a good sign. So I guess we will have to use mods instead of using mattes. So anyways, we're going to type in ls to see what we have as a directory folder. And you may notice that we have a folder called 455.120 underscore 3080. That's what we're going to pick. So we're going to type in cd 455.127 underscore 3080, given that we have a 3080. And, oh, hold on. Did I mistype it? Yes, I did. So 120, not 127. And now we're in that 455.120 underscore 3080 folder. So normally you would type in some long, awful command line like this. We type in /mods, GPU test.js, yada yada, blah blah. And this is again a huge waste of time. So instead what we're going to do is we're going to create a script file so that we can basically automate this part and not have to type in a huge line every time we want to run a mods test on a 3080. So because we want to make a file, what we're going to do is we're going to type in, we're going to call the I'm going to call the file test mod, just for simplicity. So we're going to type in nano test mods.sh, press enter. Okay, so the actual contents of the file are empty, so now we're going to type in our line, except we're going to make two adjustments. So we're going to type in /mods space GPU test.js space -oqa -ode underscore gold -test. Now this is where it changes. So typically you would pick test 178 is the one that I always get told about, but there are a couple others. So instead we're going to type in $1. This would mean argument 1 for our shell script. So then we're going to type in -DRAM clock underscore %. And then we're going to type in $2. So this is argument 2. We'll get to this, what the arguments do in a moment. And then we're going to type in -ignore underscore fatal underscore errors. And then we're going to type in space -run underscore on underscore error. And then we're going to type in -fan underscore speed 75 so the card doesn't overheat. Actually, I'm going to do 100 because why the hell not? And then we're going to type in -mat info. And that should be all of it, I think. Anyways, then we're going to press Control X. It's going to ask you to save the modified buffer. Press Y for yes. And then click Enter to save the file as testmods.sh. Okay, so now we're ready to use the file. So remember that we had a $1 and $2. This is our argument 1 and argument 2. So then we're going to type in /test mods.sh. We're going to put in 178, the $1 or argument 1, and then we're going to type in 100 for the DRAM clock percentage, or the speed at which the memory will try to run, since this was the second argument or $2. And then we're just going to press enter. In a moment it'll start running, and hopefully we'll get a usable result, but we'll have to see. I'm not sure if you can hear, but the fans are now spinning at max speed for the 3080. We'll skip straight ahead to when the test ends. Okay, so unfortunately, I think the image may have frozen. So I don't think the computer itself has not crashed. You know, I can press caps lock, and the lights LED switches between turning on and turning off. So I know the computer itself has not crashed, but the image has remained still for well over 15 minutes. So I'm going to say that maybe the card can no longer display an image. So what we're going to do is we're going to type in power off on the keyboard, and then I'm going to press enter, and we'll see if anything changes. So it seems like nothing has changed, so there we go. So just as I thought, the actual image on the monitor got frozen, but I presume that the test finished, maybe. If it hasn't, I'll run it again, and then we'll look at the mods report, I should say. Okay, so we're back in the VRAM test tools. So, since we ran mods, I should note that I actually prematurely ended mods. It was still running when I pressed power off, but that's okay because we can still find out which memory bank is faulty. So we're going to type in nano space mods.log. And it'll give you this file that you can see. So you want to start scrolling down. So typically for these mods.log photos, you want to be looking for a mat-like table. But in this case, we have something that works just fine, though it's not quite what we expected. So when we go down, we can see that we have EDC errors. In particular, you can see the EDC errors here. So no EDC errors have occurred over here. And we can see that there are 2,268 errors. And if we go down a bit more, we can see, much more importantly, that the first partition that seems to have an error is partition C over here. And again, 2,268 errors, so all the errors so far have been created on partition C. Now, you notice that it also says byte 7 and read, and again, all 2,260 errors are in byte 7. My interpretation of partition is that it refers to a memory channel. So this is memory banks C0 and C1. So if you don't know, memory banks C0 and C1 constitute 64 bits, and we have problems on byte 7. So since there are 64 bits and 8 bits in a byte, my interpretation is that the last 8 bits are the ones that are throwing errors. And so since the last 8 bits are throwing errors which is byte 7, my interpretation of course is that we have a problem with memory bank C1, or maybe I'm not interpreting the report correctly and that it's actually C0, but in either case, my first suspect is of course C1 just based off the report itself. So let's go ahead and actually no, before we do that, if you scroll down you see there are even more errors. Again, byte 7 of partition C, byte 7 partition C. In fact, if you keep scrolling down, and I should note that this file is huge by the way, but like I said, it's all byte 7 and it's all in partition C. So I'm gonna say, just as a first guess, that we have a problem with bank C1. So let's go ahead and disassemble the card. I'll show you which bank is C1 and then we'll replace it and see if the card is any more functional. Okay, so as you should have seen, we have memory errors on bank C1. So if you don't know the ordering for an RTX 3080, it is as follows: A1, A0, B1, B0, C1, C0, D1, D0, E1, E0, F1, F0. So because we have errors on memory bank C1, we by extension have errors on this particular memory bank over here, and that we need to change this one. So unfortunately, it's a corner module, as is rather common, and it's also next to the inductor, as is rather common, but it's also next to these capacitors, which will be a bit of a problem. But anyways, since we have the card disassembled, let's go ahead and take a resistance check of the PEX rail, the 1.8 volt rail, as well as the memory phase. So we're going to start with the memory phase, as I'm hoping that there's a short or something like that, so that this is quite a bit easier. But instead, we have perfectly normal resistance. So typically speaking, for an RTX 3080, you should see around 50 ohms, and in this case, we have about 54, which is again perfectly normal. So now let's check the PEX rail. So the PEX rail is typically around 5 or 6 ohms for a GA102 die, in my experience, and we have 4.7, which is again perfectly fine. And finally, we have 1.8 volts on the bottom left. So this is typically around, well, this has quite a bit of variation. So on some cards, I see, 200 or so, but on others, I often see, something in the kilo ohm range. So anyways, as you can see, we have about 1.3 kilo ohms, which again is perfectly fine. So since we have no resistances and no other further hints, let's go ahead and remove the memory bank at C1 and replace it, and we'll see if the card becomes any more functional. Okay, so as you can see, I replaced the memory module at C1. So the first thing you want to do after replacing a memory module is to check the resistance on the memory phase, as sometimes the solder balls under it get stuck together and cause a short. Okay, so 40 ohms, it's a bit lower than before, but that's because the core is still a little bit warm, so that's fine. And now let's check 1.8 volts. So this is relevant for some cards, as it uses the pump voltage, but for memory, I'm not sure if GDDR6X uses it, but we'll check it anyway. So we have 1.1.5 kilo ohms. Again, perfectly fine. Okay. So, since we're not sure, and also by the way, I changed the capacitors near the memory module, as I thought I could change the memory module fast enough that I wouldn't risk the capacitors, but in hindsight, this was a bit lazy of me, so I've just changed them anyways. So now let's go ahead and turn the card on, and as you can see, we have a BIOS splash screen, which means that the card is now in a bootable state, so let's go ahead and put the cooler on and stress test it. Okay, so you can see the card's currently running, card was running a game when I had it in my possession. So I should note that I fixed this card about 3 months ago, and the current owner of the card is he's actually a miner, and he's been mining on this card for about 3 months. And so we can kind of tell that yes, we did identify the faulty memory bank, and that we also fixed the card by replacing our faulty memory bank. So there's two things I want to go over before I end the video. To start with, I want to go over the failure modes for GDDR6X GA102 cards. So the 3080, 3080 Ti, 3090, and soon 3090 Ti. So generally speaking, if you have memory corruption on one of these cards, what you often find is that you'll have a couple of different symptoms depending on the severity of the memory corruption. For example, if you have, let's say, a mildly damaged card, then what will happen is that the card will be able to boot, but it'll crash into load, just like the 3080 you saw. If you have one of these cards, you can just go ahead and run a memory test, and you should be perfectly good. On the other hand, if you have, let's say, moderate levels of memory corruption, then you'll have a card that crashes on driver install. Now, if it crashes on driver install, again, it's the same thing. You just run your mod test, it will tell you which bank is bad, you replace it, and the card should work, assuming, of course, nothing else is wrong. Now, unfortunately, if you have, let's say, severe memory corruption, and your card hangs on post as a primary card, then memory tests are not really going to do very much for you. And that's because what will happen is that if you run, say, mats, it'll tell you that every memory bank is faulty, when in reality only a couple are suspects, but of course mats won't tell you this, and so you'll often be reduced to just replacing memory banks one by one until of course you identify the faulty memory banks. The next thing I want to go over is how we identify which memory bank is faulty. So, as you may remember, the error message for this 3080 was that it had errors on partition C. So, because it has errors on partition C, what this means is that we have memory errors on memory channel C, and that by extension, our suspect memory banks are C0 and or C1, or maybe neither of them if, let's say, you have a dead memory controller. And so, that's, of course, our two suspects. And the next part of the error message that tells us which bank is bad is the fact that it's set byte 7. If you don't know, these are memory channels. They are 64 bits each, as each memory bank is 32 bits. And what byte 7 refers to is that you have an error at the last 8 bits of your memory channel. So for example, if it said byte 0, this would be the first 8 bits, and if it was, say, byte 3, then this would be the fourth 8 bits, and by extension, the last 8 bits of C0. So if you have errors on byte 0 through 3, inclusive of 0 and 3, then you will have problems at bank C0. But if you have errors on byte 4 through 7, inclusive of 4 and 7, then you will have errors on bank C1. So because we have errors on bank 7, we had errors on the, like I said, last 8 bits, which suggests to us that we have errors on C1. And that is the memory bank replaced, and of course, as you saw, when we replaced it, the card became functional again, or at least perfectly functional. Anyways, before we end the video, there's just one more thing I want to go over. Okay, so the final thing I want to go over actually relates to my workspace. So if you're wondering why my workspace is on camera, it's because it's also my Twitch setup. If you don't know, I've recently started streaming graphics card repairs on Twitch, and basically every customer card that I get now is usually opened, diagnosed, and repaired on Twitch, including this 3090. So this 3090 was actually repaired in my very first Twitch stream. It crashed under load. It had, according to mods, it had an error at partition D, byte 1, and so we replaced D0 on the back, and now it's perfectly functional. If we boot it, it boots every time, and much more importantly, it no longer crashes under load. You can't actually see this one on Twitch, as I didn't know that you had to archive your Twitch streams manually. I wish I'd known, but it's a bit too late now. Anyway, like I said, if you send me a repair request, there's a very high chance your card will be looked at, diagnosed, and repaired live on Twitch for everyone to see, so that you don't have to trust that I worked on your card, or spent a significant amount of time on it, or did everything correctly. You'll be able to verify it. Anyways, if my channel or my videos have helped you out, consider following me on Twitch, subscribing to my YouTube channel, sending me a repair request, or telling a friend about me. It all definitely helps. And also I have a Patreon and PayPal if you want to send me donations, but it's not necessary as I now run an LLC and have a proper website. Anyways, I hope you learned something, and hopefully I'll see you in the next one, and possibly my next Twitch stream.